Electricity is all around us, powering technology like our cell phones, computers, lights, soldering irons, and air conditioners. It's tough to escape it in our modern world. Even when you try to escape electricity, it's still at work throughout nature, from the lightning in a thunderstorm to the synapses inside our body. But what exactly is electricity? This is a very complicated question, and as you dig deeper and ask more questions, there really is not a definitive answer, only abstract representations of how electricity interacts with our surroundings. Electricity is a natural phenomenon that occurs throughout nature and takes many different forms. In this tutorial we'll focus on current electricity, the stuff that powers our electronic gadgets. Our goal is to understand how electricity flows from a power source through wires, lighting up LEDs, spinning motors, and powering our communication devices. Electricity is briefly defined as the flow of electric charge, but there's so much behind that simple statement. Where do the charges come from? How do we move them? Where do they move to? How does an electric charge cause mechanical motion or make things light up? So many questions. To begin to explain what electricity is, we need to zoom way in, beyond the matter and molecules, to the atoms that make up everything we interact with in life. This tutorial builds on some basic understanding of physics, force, energy, atoms, and physics in particular. We'll gloss over the basics of each of those physics concepts, but it may help to consult other sources as well. Who discovered electricity? Electricity is a form of energy and it occurs in nature, so it was not invented. As to who discovered it, many misconceptions abound. Some give credit to Benjamin Franklin for discovering electricity, but his experiments only helped establish the connection between lightning and electricity, nothing more. The truth about the discovery of electricity is a bit more complex than a man flying his kite. It actually goes back more than 2,000 years. In about 600 BC, the ancient Greeks discovered that rubbing fur on amber, fossilized tree resin, caused an attraction between the two, and so what the Greeks discovered was actually static electricity. Additionally, researchers and archaeologists in the 1930s discovered pots with sheets of copper inside that they believe may have been ancient batteries meant to produce light at ancient Roman sites. Similar devices were found in archaeological digs near Baghdad, meaning ancient Persians may have also used an early form of batteries. But by the 17th century, many electricity-related discoveries had been made, such as the invention of an early electrostatic generator, the differentiation between positive and negative currents, and the classification of materials as conductors or insulators. In the year 1600, English physician William Gilbert used the Latin word, electricus, to describe the force that certain substances exert when rubbed against each other. A few years later, another English scientist, Thomas Brown, wrote several books, and he used the word, electricity, to describe his investigations based on Gilbert's work. In 1752, Ben Franklin conducted his experiment with a kite, a key, and a storm. This simply proved that lightning and tiny electric sparks were the same thing. Italian physicist Alessandro Volta discovered that particular chemical reactions could produce electricity, and in 1800 he constructed the voltaic pile, an early electric battery, that produced a steady electric current, and so he was the first person to create a steady flow of electrical charge. Volta also created the first transmission of electricity by linking positively charged and negatively charged connectors and driving an electrical charge, or voltage, through them. In 1831 electricity became viable for use in technology when Michael Faraday created the electric dynamo, a crude power generator, which solved the problem of generating electric current in an ongoing and practical way. Faraday's rather crude invention used a magnet that was moved inside a coil of copper wire, creating a tiny electric current that flowed through the wire. This opened the door to American Thomas Edison and British scientist Joseph Swan, who each invented the incandescent filament light bulb in their respective countries in about 1878. Previously, light bulbs had been invented by others, but the incandescent bulb was the first practical bulb that would light for hours on end. Swan and Edison later set up a joint company to produce the first practical filament lamp, and Edison used his direct current system, DC, to provide power to illuminate the first New York electric street lamps in September 1882. Later in the 1800s and early 1900s, Serbian-American engineer, inventor, and all-around electrical wizard Nikola Tesla became an important contributor to the birth of commercial electricity. He worked with Edison and later had many revolutionary developments in electromagnetism, and had competing patents with Marconi for the invention of radio. He is well known for his work with alternating current, AC motors, and the polyphase distribution system. Later, American inventor and industrialist George Westinghouse purchased and developed Tesla's patented motor for generating alternating current, and the work of Westinghouse, Tesla and others gradually convinced American society that the future of electricity lay with AC rather than DC. Others who worked to bring the use of electricity to where it is today include Scottish inventor James Watt, André Ampère, a French mathematician, and German mathematician and physicist George Ohm. And so, it was not just one person who discovered electricity. While the concept of electricity was known for thousands of years, when it came time to develop it commercially and scientifically, there were several great minds working on the problem at the same time.